Hello everyone, welcome to Education in Hands. In this video, we are going to see what is a load and what are the types of loads and its different combinations according to Indian standards. So first, if we see what is load or the definition of load, it is the force that acts on a structure. So whatever the force or combination of forces that are acting on the structure is termed as load. For a safe and economical design, one should have good knowledge on various types of loads and their worst combinations which leads to failure of the structure in mind. So for us it is good to know the knowledge of loads and their combinations and how loads are acting from different sources on a structure in this video. So according to IS 800 2007 in clause 3.2.1, loads are defined into different types like this, from dead loads to secondary effects. If we see here, dead loads to accidental loads are the actual loads or forces which are acting on the structure, whereas secondary effects is associated with these loads and acting on the structure to failure. So let us see one by one about these loads and how we are going to calculate and what are the codal provisions that are provided for us to calculate these loads in detail. First one is dead loads. So as per clause 3.2.1.1 in IS 800 2007, dead loads are like the weight of all permanent construction which is associated in a structure. So if we construct a building, bricks which is used for walls or the windows, doors, slabs, roofs, everything which is permanent in construction, the weight of those permanent construction materials is considered as dead loads. So how we are going to calculate this dead weight? We are going to access this by estimating the quantity of each material and then multiplying with its unit weight. So if we are going to construct a wall with 1000 bricks, we need to take the weight of one brick, then we will quantify it with 1000 bricks. Likewise, we are going to get the dead weight or dead load which is acting on the structure. So unit weight of different materials which are used in construction are given in IS 875 part 1. In table 1, it is given like this. What is the unit weight of each material that is used in our construction? So from this table 1 of IS 875 part 1, we can take the unit weight of a material and we will get the total dead load acting on a structure. This is about dead loads. Next one is imposed loads. According to IS 800 2007, clause 3.2.1, imposed loads are classified or subdivided into these categories from live load to horizontal loads. So here, first of all, imposed load means the load which is acting for certain time or for temporary basis, then it will be removed. Example, if we take a live load is like which is standing in the structure for temporary basis, like furniture or living habitants which are staying in the house for a temporary time and then we can remove it or replace it somewhere. So such kind of loads are imposed loads. So the first one is live load. Live load means if it is in a building, the furniture, the habitants which are living there, all will come under live loads. Whereas if it is in a bridge, then the vehicles which are passing through the bridge will come as a live load. Likewise, all the live loads and their considerations are given in IS 875 part 2. The next one is crane load. Crane load is like the installation of crane, its weight, which is acting on the structure at the time of construction. So at the time of construction only, crane load is there on the structure. Then after the construction is over, it is removed. So it is also coming under imposed load. Next one is snow load. The snow load is acting on a structure only when there is an snowfall. After that, when snowfall is reduced, there is no need of snow load considerations. So it is also an imposed load. The next one is dust load. This is majorly considered in areas where dust formation is more. It is also a type of imposed load. Next is hydrostatic and earth pressure, which is classified in IS 875 part 5. This is an subsurface load which is acting on the structure at the time of construction or when there is an hydrostatic pressure. The next one is impact load. Impact load will act on a structure suddenly with certain impact, which is also a temporary load. And last one is horizontal loads on parapets and balustrades. So whenever we are climbing steps, we use balustrades. So as a support. And also in balconies, we use parapets for supporting. So at that time, there is an horizontal load we are applying on that balustrades and parapets. This is also a temporary load. So we are considering it in the imposed load category. So all these loads will come under imposed loads. So the next one is wind loads. According to clause 3.2.1.3 of IS 800/2007, wind load means the force exerted by horizontal component of wind is considered in the design of structures like buildings, bridges and towers, where this horizontal force of wind will exert pressure on the structure. So it is considered as wind load. So the wind force or the wind load mainly depends on the velocity of wind, shape, size and location of the building. Like if we consider two buildings which are located on hilltop and in plain terrain, those two are having different wind action. The building which is on the hilltop will experience more wind load than which is in the plain terrain. So it is also an important consideration in wind loading. The next complete details of calculating this wind load on structures is obtained from IS code 875 part 3. So if we see briefly how we are going to calculate this wind load, first we will calculate design wind velocity, which is Vz equal to K1, K2, K3 into Vb, where K1, K2, K3 are coefficients given in the IS 875 part 3. First one is K1, which is called risk coefficient, and then K2 is the terrain coefficient and K3 is the topography factor. All these three we can calculate from IS 875 part 3 itself. The next one is VB, which is the basic wind pressure. Depending upon the location, different locations in India having different wind pressures. So from IS 875 part 3, we can take basic wind pressure for different locations using the map available in the code. The next, design wind pressure PZ is calculated from Vz, which is equal to 0.6 Vz square, which is the design wind pressure for our design. So up to 30 meters height, wind pressure is considered to act uniformly, but above 30 meters height, it is taken as increasing way. So up to 30 meters design is basic one, then above 30 meters wind load design is differing from basic design. The next one is earthquake load. About this load, it is given in clause 3.2.1.4, but that is just a basic. But the design is completely given in another code. So first, what is an earthquake and how it is causing damage to the building means it causes movement in the structure in vibratory fashion first. So whenever an earthquake occur in an area, it cause vibratory motion movement in the structure. The total vibration caused by this earthquake is resolved into three components, one in vertical and two in horizontal directions. So these two horizontal directions are considered in earthquake resistant structural design. IS code 1893 part 1 is the code for calculating these seismic forces and designing the building which is resistant against earthquake loads. So two methods are used for computing these seismic forces generally, which is seismic coefficient method and response spectrum method. This is about earthquake load basically. If we go in depth, it will become an another subject. So we will skip here. So next one is erection loads. These are the loads basically carried by the structure due to storage or positioning of materials and also erection equipment which is used at the time of erection. Along with these loads, dead loads, wind loads and also such parts of the live loads would be imposed on the structure during the period of erection are all together considered in the erection loads. To take care of these erection loads, proper provision shall be made including temporary bracings to take care of all stresses developed at the time of erection. So if we take care of these erection loads, then after its removal, we can safeguard the structure. Then next one is accidental loads. According to IS 875 part 5, these accidental loads are majorly classified into three types. Those are impact and collision. Then second one is explosion and third one is fire. Basically, the probability of occurrence of these loads is very small. But if it occurs, the consequences lead by these loads are very severe. That's why we need to take care of these loads also. Then the last one is secondary effects which are caused by these loads. It is given in clause 3.2.1. According to this clause, the following types of secondary effects should be looked into the design. So what are those secondary effects? Differential settlement of the foundations. So one foundation is here and another foundation settled down. This is called the differential settlement. We need to consider that one. Then differential shortening of columns. If one column is shortened than another column, then it is also an effect. Then eccentric connections. If a connection is having eccentricity, then it will lead to some more stresses. We need to take care of that one also. And next, rigidity of joints differing from design assumptions. So all these secondary effects we need to consider in the design. So designer has to look into various loads likely to act during the life of a structure as per codes given by the Indian standards. Otherwise, the structure may lead to failure or it may be prone to any loading. So generally, the loads which we discussed here will not act on the structure as a single entity. Basically, these loads will act either one or two or it may be multiple together. So, for that reason, in clause 3.5 of IS 800-2007, some load combinations are specified while designing the structure. See here, load combinations for design purpose shall produce maximum forces and effects and also consequently maximum stress and deformations. So, the following combinations of loads with appropriate partial safety factors are considered in the design. In that combinations, first one is dead load plus imposed load. In basic design, we need to calculate these two, dead load plus imposed load, as a single entity. For example, if we consider a building or house which we are staying. So in our house, first one is dead load, means the entire house is constructed with certain materials, that is the dead load, and then we are living. So the persons whom we are living and the utilities like bed, cot, sofa, whatever the furniture we are using, all together will come as a live load. So in basic design of a structure, dead load plus imposed load is the first combination of load. The next one is dead load plus imposed load plus wind or earthquake load. So either we need to take wind load or we need to take earthquake load, but not together. The next, dead load plus wind load or earthquake load. And the last one is dead load plus erection load. So in the cases C and D, we are not taking much care of imposed load. Why? Because if we take care of wind or earthquake or erection loads, it will take care of the imposed load also. And here one important thing we need to remember is wind and earthquake loads shall not be assumed to act simultaneously. This is the codal provision. Their effects shall be considered separately always. Along with this, in clause 3.5.3, effect of cranes to be considered under imposed loads shall include vertical loads and its eccentric effects and impact factor, and also lateral and longitudinal thrusts. Next one is 3.5.4, crane loads and their combinations to be considered shall be indicated by the customer. Otherwise, in their absence, their combination shall be considered in accordance with the provisions provided in IS 875 Part 2. And then in 3.5.5, while investigating the effects of earthquake forces, effects from dead loads of all cranes which are parked in the bay and positioned to cause maximum effect will also be considered. So all these combinations and guidelines are clearly given in IS 800-2007 clauses. Then next one is clause 3.5.6. The crane runway girders supporting bumpers shall be checked for bumper impact loads also, as specified by the manufacturers. And then 3.5.7, stresses developed due to secondary effects shall be appropriately added to the stresses calculated from the combination of loads. So whenever we are going to design a structure and the loads which are acting on the structure we are considering, means we need to keep all these things in our mind. So this is about loads and their combinations. Thank you. See you in the next video. Bye.